Hello everyone, myself Suraksha. My topic is analysis and presentation of data and descriptive analysis. Firstly, we have to see the analysis and presentation of data. Data analysis involves processing and analyzing the data to derive meaningful insights. It analyzing the data gathered from customer survey, conducting interviews, or reviewing case files. Next, presentation of data. Presentation of data involves presenting the data in clear and conscious way to communicate the research findings, such as charts, graphs, maps, dashboards, animations, etc. Data analysis techniques. So, first one, descriptive statistics. Descriptive statistics involves summarizing and describing the data using measures such as mean, median, and standard deviation. Next one, inferential statistics. So, in this statistics, involves the techniques like hypothesis testing, confidence intervals, and regression analysis to making the inference about the population based on the sample data. Next one, content analysis. Content analysis involves analyzing the text, images, or videos to identify patterns and themes. Next one, data mining. In this step, involves the statistical and machine learning techniques to analyze large data sets and identify the patterns. Next, second one, data interpretation techniques. Data interpretation means review data and arrive at relevant conclusions. In that, various techniques are involved. First one, data visualization. It involves presenting the data in a visual format such as charts, graphs, or tables to communicate the insights effectively. Next, second one, storytelling. It involves presenting the data on the basis of narrative format such as story to make the insights more relatable and memorable. Next one, comparative analysis. In this comparative analysis, comparing the research into existing literature or benchmark to draw conclusions. Next, third one, data presentation techniques. Data presentation means it is the presenting the data in a clear and conscious way to communicate the research findings. So, in that, common data presentation techniques are tables and graphs. Tables and graphs are effective data presentation techniques for presenting the numerical data. Next, infographics. Infographics means collection of imagery data visualizations like pie chart and bar graphs. Next, data storytelling. Data storytelling means presenting the data on the basis of research narrative format to communicate the research findings effectively. Next, so overall conclusion of this is analyzing and interpretation and presentation of crucial interpretation of conducting high quality research. By using the appropriate data analysis, interpretation, and presentation techniques, researcher can derive meaningful insights, make sense of the insights, and communicate the research findings effectively. Next, descriptive analysis. Descriptive analysis means identifies patterns in a data to answer questions about who, what, where, when, and to what extent. For example, year over year pricing changes and month over month sales growth. This is the example of the descriptive analysis. Next, types of descriptive analysis. First one, measurement of frequency. Measurement of frequency is a number of times a value of the data occurs. In that, the example is the table. There are 3 students who work 2 hours, 5 students who work 3 hours, so on. The sum of the values in the frequency column 20 represents the total number of students included in the sample. Next, this is the example of measurement of frequency. Next, second one, measurement of central tendency. So, in this, 3 standards are used. Mean, median, mode are used to calculate the central tendency. Next, third one, measures of dispersion. This kind of distribution may be measured using dispersion matrix like range or standard deviation. Next, fourth one, measures of position. Finding a values or responses location concerning other matters is another aspect of descriptive analysis. In this area of knowledge, metrics like quartiles and percentiles are beneficiary. For example, in schools and universities, measures of position such as percentiles are often used to compare the students' performance. This is the example of measures of position. Next, how to conduct a descriptive analysis. First step, data collection. While conducting descriptive analysis, first step is to collect the relevant data and identify and select the appropriate in that and verify the data. So this is the first step. This step covers the following tasks: data cleaning. Second one, next one, data preparation. Data preparation means it is for the process of gathering, combining, structuring, and organizing data for use in business intelligence, analytics, and data science applications. It includes cleaning, pre-processing of the data. Next, third one step, apply methods. This is next step is applying various methods to analyze the data like frequency distribution analysis, measures of central tendency, measures of dispersion, measures of position. Next, last step is summary statistics and visualization. Last step is summarizing the data. In this data can be summarized numerically in the form of a table known as tabular summarization or visually in the form of graph known as data visualization. Conclusion. Descriptive analysis is a crucial research approach regardless of whether the researcher wants to discover causal relationship between variables, explain population patterns or develop new metrics for basic phenomenon. When used correctly, it may significantly contribute to various descriptive and causal research investigations. This is the conclusion of the descriptive analysis. Thank you.
Hello everyone, myself Akshaya Shetty. My topic is choosing the appropriate statistical technique and univariate statistical analysis. Introduction. Choosing the right statistical technique means picking the best method to analyze the data effectively. It depends on what type of data you have, what you want to find out, and ensuring the methods fits the assumption and size of the data. It's about matching the right tool for the job to get accurate and meaningful result. A wrong selection of statistical method not only creates some serious problem during the interpretation of the findings but also affect the conclusion of the study. Next, factor influencing the selection of statistical methods. It depends on the following three things: aim and objective of the study, time and distribution of the data used, and nature of the observation. The first one, aim and objective of the study. Objective are specific, measurable, and achievable goals that outline what the researcher will accomplish in order to achieve the aim of the study. The aim provides a broad statement of what the study intends to accomplish. Selection of statistical test depends upon our aim and objective of the study. Suppose our objective is to find out the predictors of the outcome variable, then regression analysis is used while to compare the means between two independent samples. Unpaired samples t-test is used. The second one is type and distribution of the data used. For the same objective, selection of the statistical test is varying as per data types. For the nominal, ordinal, discrete data, we use non-parametric methods, while for continuous data, parametric methods as well as non-parametric methods are used. Third one is observation are paired or unpaired. Another important point in selection of the statistical test is to assess whether data is paired or unpaired. Paired means same subjects are measured at different time points or using different methods. Unpaired means each group have different subject. And next, univariate statistical analysis. Univariate is a term commonly used in statistics to describe a type of data which consists of observation on only a single characteristic or attribute. It focuses on analyzing one variable at a time. It involves examining the distribution, central tendency, variability, and other characteristic of a single variable without considering relationship with other variables. For example, salaries of workers in industry. Like all the other data, univariate data can be visualized using graphs, images, or other analysis tools after the data is measured, collected, reported, and analyzed. Univariate analysis is the simplest form of analyzing data. Uni means one. So the data has one variable. Univariate data requires to analyze each variable separately. Data is gathered for the purpose of answering a question, or more specifically a research question. Why univariate statistic? Univariate analysis explores each variable in a data set separately. It looks at the range of value as well as the central tendency of the values. It describes the pattern of response to the variable. It describes each variable on its own. And next, categorical univariate data. Categorical univariate data consists of non-numerical observation that may be placed in categories. It includes labels or names used to identify an attribute of each element. First one, numerical univariate data. These are the data where each observation is represented by a single numeric value. This type of data allows for quantitative analysis and includes a wide range of measurement and counts. These have two subcategories. First one is descriptive statistic. They are used to summarize and describe the key features of a data set. Second one is inferential statistic. They are used to make inferences or prediction about a population based on sample data. And second one, measures of central tendency. They are used to describe the center or average value of data set. Central tendency is one of the most common numerical descriptive measures. It's used to estimate the central location of the univariate data by the calculation of mean, median, and mode. Each of these calculation has its own advantages and limitations. Third one is measures of variability. A measure of variability or dispersion of a univariate data set can reveal the shape of univariate data distribution more sufficiently. It will provide some information about the variation among the data values. Descriptive methods. Descriptive statistics describe a sample or population. They can be part of exploratory data analysis. Inferential method. Inferential method allows us to infer from a sample to a population. For a nominal variable, a one-way chi-square test can help determine if our sample matches that of some population. Conclusion of univariate statistical analysis. The conclusion for a univariate statistical analysis depends on the specific objective and findings of the study. It involves summarizing key results, discussing any patterns or trends observed, interpreting statistical measures such as mean, median, mode, standard deviation, skewness, and kurtosis, and drawing implications for the research question or hypothesis. It may include recommendations for further research or practical applications based on the analysis outcomes. Univariate statistical analysis serves as a foundational approach to understanding and summarizing single variables within a data set. By focusing on one variable at a time, it provides valuable insights into the central tendency, dispersion, and distribution of the data. Thank you.
Myself Saksha. My topic is bivariate analysis and multivariate analysis. First one, meaning of bivariate analysis. Bivariate analysis refers to the data that involve exactly two variables. The analysis of bivariate data focuses on the relationship between these two variables. For example, studying the correlation between the height and weight of individuals would involve the bivariate data analysis. Uses of the bivariate analysis. First one, bivariate analysis can be useful in evaluating the basic association hypothesis. Second one, the degree to which it becomes simple to understand and anticipated a value for one variable can be determined with the aid of bivariate analysis if we are aware of the other variable values. Types of the bivariate analysis. First one, scatter plots. A visual representation of bivariate data where each observation is plotted as a point on the graph with the two axes, so one for each variables. It has visualized the relationship between the variables. Second one, regression analysis. This examines the relationship between a dependent variable and an independent variable. Simple linear regression involve the one independent variables, while multiple linear regression involve the more than one independent variable. Next, correlation coefficient. It is a statistical measure that describe the strength and directions of the relationship between two variables. It range from -1 to plus 1, where +1 indicate a perfect positive relationship, -1 indicate the perfect negative relationship, 0 indicate a no relationship between the variables. Next, multivariate data. It refers to the data that involve the more than two variables. The analysis of the multivariate data consider the simultaneous relationship between the multiple variables. For instance, a study of the economic factors affecting a country GDP variables such as inflation rate, unemployment rate, and government spending would be constitute the multivariate data. The multivariate analysis is more complex form of the statistical analysis techniques and used when there are more than two variables in the data set. Commonly used of the multivariate analysis techniques includes first one factors analysis, second cluster analysis, third one variance analysis, fourth one discriminant analysis, fifth one multidimensional scalings, and sixth one redundancy analysis. Advantages of the multivariate analysis. First one, using multivariate analysis, you can make prediction about future event. For example, can predict customers' behavior, the likelihood of the loans default, or the outcome of the sporting event. Second one, multivariate analysis can identify a pattern in your data. You can understand how your data is distributed and identify trends and anomalies. Next, third one, it can be used to understand the relationship between different variables in your data. This can help you understand how variables affect each other and to identify any causal relationship. Thank you.